All right, hi there, Algebra 2 students. One more time, we need to take a look at this first page and cross off the word trinomials. On the next slide, I'm going to explain why that's the improper word to be used. So welcome to your notes on the sum and difference of cubes. All right, so you're probably wondering, why the heck does Mr. Bear keep having me cross off that word trinomials, okay? These are actually cubic binomials, all right? You take a look at that first term in the polynomial that you're dealing with. So when we're dealing with these in this section today, we're really dealing with this side over here, okay? And so while we're doing that, when we're dealing with this side over here, this is called a cubic because of the highest degree in this initial monomial, or this initial term. So it's called a cubic because it's raised to the third power. It's called a binomial because you have 1, 2 terms. So bi means 2, and so you have a cubic binomial. So hopefully that explains it. Also, you need a little parentheses right there. So you might add that into your notes as well. So anyhow, that's why I had you erase that word trinomial on that first page of both of the last set of notes. Now, let's talk about the sum and difference of cubes. This initial page here that we're dealing with shows you your cipher, if you will. It's your code, if you will, so that you can crack the code. So you need to pay attention to when you have an A term that is to the third power and a B term to the third power. You can use either one of these formulas to crack the code. So here we go. We're going to show you how to use these. Okay, so I didn't have enough time to sit there and work through every single one of these for you because YouTube does limit my time. So on this page, I need you to memorize every single one of these cubes. On to the next page. Okay, hopefully you realized that I was being humorous. You don't need to memorize that. That's why we let you use your calculators. Okay, so when we are dealing with the sum and difference of cubes, I need to realize that I have a formula for this, and A in this particular case is equal to x. All right? B in this particular case is the cubed root of 8. And one of the reasons why we take a look at that first page to talk about those cubes is because you need to realize that the cubed root of 8 is 2. So really, I need to plug both of these into my formula. So I would have A, which is A plus B inside of a set of parentheses in my formula, multiplied by A squared minus AB plus B squared. Okay? And let's change colors here because really I'm going to have right below that x plus 2 multiplied by A, which is x squared, minus AB, so 2x is how we write that in algebra. We don't write it as x2, all right, plus 2 squared. Now I need to do a little bit of work here because 2 squared I can actually compute. So I've got x plus 2 multiplied by x squared minus 2x plus 4. And I'm done. All right, like I said, I need you to have that 729 memorized so you know if that's a difference of cubes or not. Just kidding. I do expect you to be able to recognize that you probably have a difference of cubes here, though. So our formula says that this is really equal to A minus B multiplied by A squared plus AB plus B squared. Okay, so in this particular case, my A, well, it's equal to A. And my B is equal to, well, 729. The cubed root of that is 9. Okay, so right below my formula, I'm just going to plug everything in. So I've got A minus 9 multiplied by A squared plus, I'm going to say 9A plus b squared, and I'm going to write it like this, even though some of you probably will go ahead and do 9 squared and just write it right there, and then I'm going to write the rest of my work, because really I'm just copying down all of the rest of this so that I can write 81 at the end of that line of work. Okay, moving on. Okay, in this particular case, A is going to be a little bit more challenging to come up with, but I still think that you're capable of it. So let's do some side work over here. I need to come up with the cubed root of 512x to the third, and we would have a little 3 in our index of our radical right there. And so that's not the world's greatest looking 3, but I think you get my point. Okay, so 512 multiplied by x to the third. Well, I can rewrite this kind of like this and put an index of 3 there. 512 multiplied by the cubed root of x to the third. And really this is 8 multiplied by x. Hopefully you can see that as I kind of broke that down for you. So this is the sum of squares. So our formula for that is a plus b multiplied by a squared minus ab plus b squared. Okay, so right below all of that, I'm just going to go ahead and plug in what I have. Okay, so I have a, which is equal to 8x. My b, well, let's figure out what my b is going to be. Let's see, so 64, the cubed root of that would be 4. Okay. All right, so when I start doing my work, I'm going to leave myself plenty of space here because I know it's going to take some time, or it's going to take some space anyways. So a is equal to 8x. Okay, so I've got, let's change to black here. 8x plus b, which is 4. And you might notice why I put these inside of parentheses like I've done here in just a minute. Now, a squared is 8x squared, and it's got a parentheses like that. All right, minus a, which is 8x, multiplied by b, which is 4, plus, I still didn't have enough space, b squared. So 4 squared. All of that is inside of a set of parentheses. And let's fix this little 8 right here if I can. There we go. Now, this first piece of the factor, I don't really need to change that. So I'm just going to call that 8x plus 4, if it allows me to actually make it look like that. Okay. 8x squared, let's do some side work down here. 8x squared is equal to 8x multiplied by 8x. So really this is 64x squared. Hopefully you can catch up with what I'm doing here, or keep up with what I'm doing here. So 64x squared goes right there. Minus, well, let's see, 8x multiplied by 4, that's going to give me 32x. And then 4 squared, that's 16. So this is what my factors will look like. Okay, hopefully you're starting to catch on. I'm going to go ahead and kind of skip some of that side work that I had done on the previous page there. So I'm just going to ask you, okay, so what is my a value? All right, well, the cubed root of 1,000, that's 10. And then the cubed root of x to the third would just be x. So my a here is going to be 10x. For my b value, I need to analyze that 125. Okay, so 125, the cubed root of that is 5. And I have here the difference of cubes. So according to my formula, I need to do this as my factors. A minus b multiplied by a squared plus ab plus b squared. Okay, so those are my factors. All right, let's kind of hold this down. I'm pretty sure I can do a finer tip. Let's do a finer tip. There we go. I need a finer tip. Let's go to that one. Okay, so A is equal to 10x, so I've got 10x minus B, which is 5. Okay, in the other factor, I've got A squared, so I've got 10x inside of parentheses squared plus AB, so 10x multiplied by B, which is 5, plus B squared, so 5 squared. Oh, barely had enough space there. Okay, so let's change colors here. The 10x minus 5, well, we can't really simplify that any further. However, I can simplify this term. 10 squared would give me 100, and then x squared would give me x squared, plus 10x multiplied by 5, so that's going to be 50x, and then 5 squared is 25. All right, there you have it. All right, we're on problem number 5 here, so we've got 24x cubed plus 3, that's the sum of cubes. My a value is equal to, well, let's see, 24. I can't really come up with the cubed root of 24 right off the bat too easily. So let's do a little bit of work here. I've got the cubed root of 24x to the third. Okay, now I am going to look for some numbers in that can be a perfect cube. Now I know that 8 is a perfect cube, so I'm going to break this down a little bit. I've got 8, and I can multiply 8 by 4, and then my x to the third is still inside of there. Okay, and I can break that down even further by saying, okay, well, I've got the cubed root. I don't know why it just changed there. I've got the cubed root of 8 multiplied by the cubed root of 4 multiplied by the cubed root of x to the third. All right, so what I'm going to do is I'm going to leave that cubed root of 4 right there as part of my answer. I can pull out a 2 from here, and I can pull out an x from here. So my answer for the cubed root, or my a value, is really 2x multiplied by the cubed root of 4. All right, so a would be equal to 2x multiplied by the cubed root of 4. B would be equal to the cubed root of 3. Now, quite honestly, I stopped the video at this point just a second ago and did quite a bit of work on my page because I started to tear into this thing and realized, oh my goodness, this one's going to get messy. So I'm going to pause the video and put some of my work on here because YouTube does limit my time. So I'll be back shortly. Now, I know at this point some of you are already blurting out in class saying, there is no way I can do this. And yes, you can, but here's what I'm going to tell you. I promise you that you are not going to see one on a quiz or a test that goes into this much detail. Now, all right, I noticed a mistake in here, right there, whenever I was recording this before, plus I realized I went over 15 minutes with my explanation. So, again, please don't worry about trying to copy all of this down because I'm not going to give you one that's quite this difficult on a quiz or a test, but I wanted you to see some of my work when I squared this term right here. I got 4x squared multiplied by the cubed root of 4 squared. This right here was the mistake I had. I forgot that little squared exponent there. When I multiplied this term right here by the cubed root of 3, I can't really reduce that any further, so I just left a cubed root of 12 there, 3 times 4. And then I rewrote this as an exponential form instead of a rational form like that, or a radical form like that. So hopefully that helps you with your explanation.